lab. Thanks for being my partner today. I'm excited to show you a limiting reactant lab, or also the production of silver. You need to have the limiting reactant lab handout ready so that you've got a place to record your data to get the information that you need to do this lab. So if you don't already have that, go ahead and pause the video. And then when you're ready, come on back and let's do this lab together. Let me just show you the setup of the things we're going to be using for this lab. So you'll see that we've got a balance, we've got our silver nitrate, we have copper, we eventually will use some acetone and some filter paper, we've got some glassware and some DI water that we need, scupula, stir rod, all that kind of stuff. All right, so those are the supplies. So we're gonna do that thing that sometimes happens where you probably won't see much of me in the video, you're gonna see the chemicals and what's happening instead. All right, so you should have already done the pre-lab so that you know what the reaction is that's going to be happening. It's a single replacement reaction between copper and silver nitrate. The copper is going to be solid, you'll see it. We're going to make an aqueous solution of our silver nitrate, and we're going to let that reaction happen for a few hours until we make sure that it finishes, and then we're going to filter out the silver, and then we're going to mask the silver so that we can eventually figure out what the percent yield is for our reaction. That's the whole point of this lab. All right, let's go ahead and get started. So your pre-lab should be done. Your hypothesis you will do after you get these first two pieces of data, and then you'll be able to continue from there. You can follow along on the procedure as needed. Otherwise, you can just watch what's happening in the video, record the information as we show it. All right, so what I've got here is I've got my setup. So I'm going to start by taking my beaker, and I'm going to put this, make sure my balance is on first of all. Okay, so I'm going to make sure that my balance is at 0, so I hit my 0 button so it goes back as if there's nothing on top of there. And then I'm going to add about 1 gram of my silver nitrate. You can see it's kind of that whitish crystals. And so I'm going to add there. I'm going to go a little bit slow because it goes kind of quickly. Ooh, that was a big clump. So just a little bit. Trying to go slow so I don't have to take any out. And I'm trying to go for at least 3 sig figs. So I don't want to stop at like 0.99. I'm trying to go to like 1 point something. Ooh, there we go. This will work. All right. So we see our balance there. 1 point, wait for it to stop changing, 1.07. So 1.07 is what we're going to record for the silver nitrate, 1.07 grams. So put that in your data table. All right, the other piece of data that we need, so I'm going to take this off for now, is we need the mass of our copper. I am going to use just like my shirt to just wipe off the copper, make sure there's nothing from the lab on there. It's been sitting in the chemical storage room for a while, so try to get that as clean as possible. And then once again, I'm going to make sure my balance is at 0 because I want the mass of just this little piece here. So I put that on there. I'm going to get it so that it's all on the balance and not overlapping. And then let's check that out. Looks like it's staying at 1.47. So 1.47 is my grams of copper, 1.47 grams of copper before the reaction. So we got those filled in there for my silver nitrate and my copper before the reaction. Those are the two givens that you will use to write your hypothesis. So the idea is that we're going to let these two things react. One of them is going to run out first. That will stop the reaction. That's our limiting reactant idea. Then that's what we'll use to be able to predict the amount of silver we actually make in the lab. We have our prediction and our hypothesis of what should be made, of course, that's the hypothesis, but eventually we'll measure what we actually made. Okay, back to our lab here. So let me show this back to you. Okay, so now I've got my silver nitrate, but it's solid and this doesn't fit in here, so they can't really react. So I'm gonna take the cover off my DI water. The water is not part of my calculation, so I can just use my beaker and just estimate the 100 milliliters. So I'm just gonna pour that in there. It's not a specific measurement, so I just can do a kind of an approximation. I pour it just so that it goes faster. I'm gonna need my squeeze bottle later, so I'm gonna put the cover back on. All right, and then I'm gonna just let that kind of mix. I'll swirl it a little bit. If it doesn't seem like it's dissolving, I could use my stir rod, but then that's just one more thing I have to wash. So I'm going to just kind of try to swirl it and get that all to dissolve. So trying to make that silver nitrate solution, so aqueous because it's mixed with water. While that's kind of mixing, I'm also going to take my piece of copper wire, and I need to get it to get in there so it actually fits. In your lab, you'll see that there's a figure 1 that it shows you. What I'm going to do is basically take the copper and kind of wrap it around my finger and then create a hanger at one end. And I'm going to stretch this down so that this gets into the solution as much as possible, kind of measured on the outside. Yep, it looks like that's going to fit in there pretty good. And then make sure my silver nitrate is all dissolved. Yep, looks like it is. I'm looking at the bottom of it. It looks totally dissolved. And then I've got my copper, and I'm going to drop that in there so that the copper now can react with the silver nitrate. And then you can see, like, you can already kind of see some little bit of color change happening. But now we're going to let this reaction sit here for a while and let this single replacement reaction finish. While you're waiting for it, you could go ahead and do your hypothesis. But for now, we're going to do time lapse and let time go by. I'll check in with you again when the reaction is done. See you in a little bit. Hey, welcome back. Ready for part 2 of our lab? I'm glad you joined me. So let's check in as to what happened during the time we were away. Okay, so we've got remember when we last were together, we left our copper in our silver nitrate solution and we were waiting for a single replacement reaction to happen. Are you ready for it? Here's what it looks like now. How amazing is that? So what has happened is, because copper is strong enough, copper has replaced silver with the nitrate compound. So now there's copper 2 nitrate solution. That's kind of the bluish liquid. And then you can literally see that silver that has formed on the outside of the copper. How great is this chemistry? This is pure silver. Well, it's silver mixed with other things, but it's pure silver atoms mixed with stuff. We're going to try to get the silver all by itself so we can get the mass of it and figure out the percent yield of this reaction. So what I'm going to do is I'm going to take the copper and I'm going to kind of knock all the silver off of it, because I want all the silver in the solution for when I filter it. I don't want any silver left on here. So I'm going to knock all that silver off, and now I can see the copper. You can kind of see the discoloration where some of those copper atoms were replaced. And then, so it looks different than the top part that was not in the solution. So I get rid of all the silver on there. And then what happens now is I want to know how much copper was left over after the reaction. But right now, it's wet. It's got copper nitrate on it and some water. And so I don't want to put this right on the balance. I need to clean it first. So what I'm going to do is I'm going to dip this copper wire in a beaker of acetone. Acetone is kind of like fingernail polish remover. And what will happen is it will clean off any of the solution, the copper 2 nitrate that's on here, but then it will also dry really fast. So I dip the copper in there, and by the time I take it out and just leave it to sit for a little while, it's already dry. So now it's clean and dry. I go to my balance. I make sure my balance says 0.00. I take my clean and dry copper wire and I put it on the balance. And we take a look at the mass, 1.30. It went down, which we would expect because some of those copper atoms transferred to this copper nitrate solution. So 1.30 grams is the copper after the solution. The next thing I need to do is I need to take a piece of filter paper, and that filter paper is going to be used to filter the solid silver from the aqueous solution. So I need to know the mass of my filter paper before I start filtering, so that in part 3, when I get the mass of the silver and the filter paper, I can figure out how much just silver I have. The copper wire I'm going to throw away, and then I'm going to take my piece of dry filter paper, make sure that it is at 0.00, which it is, and then I put that on the balance, and then I get the mass of just my filter paper, and it looks like it's staying at 1.09. So the mass of just my filter paper is 1.09. So now this is what your data should look like. So combining the stuff from part 1, now the stuff from part 2, we've got all of our data from part 2. And so now I am ready to start filtering. So let me show you what I'm going to be doing here. So I'm going to take my filter paper and I'm going to fold it in half. And then I'm going to fold it in half again. This makes a proper filter. And then I'm going to see how there's 4 layers. I'm going to separate it so it's 1 layer on one side and 3 layers on the other. That creates a continuous cone. And then that's going to go in my Erlenmeyer flask and my funnel. So the filter paper is in the funnel, and then it's shaped like this so it doesn't splash. The funnel sits in it really nice. And then I'm just going to start filtering. So I'm going to pour as much as I can into this filter, because it turns out that this filter works through gravity filtration, meaning the more weight that is in this funnel, the more it pushes on itself and pushes through. So you can see the filtering has started. And then you can kind of see, I'll show you in the top there. So I'm just going to keep filling that and filling that and filling that, and then filter as much as I can out of here. And eventually, I'm going to get all of these solid pieces. So all of these solid silver chunks that are in there, I'm going to get them in my filter as well. So I might do a little bit of time skipping during this, but what I'm going to do, and I'll make sure you see this at the end, I'm going to make sure that everything from this beaker is inside this funnel, because then that way all of my lab sample will be measured, all the aqueous pieces will go through, and any solid chunks like the silver would stick in my filter paper. So you might see the video skip ahead a little bit, but eventually I'll show you at the end where everything from here is in my filter, and then I'll just let that finish over until part 3 is ready. Okay, so as this continues to filter, you can kind of see the copper 2 nitrate solution. Maybe you can see that it's kind of this light blue copper 2 nitrate. And then I've got some silver pieces and some other things that are kind of sticking in the funnel. You can kind of see that. And so what I'm going to do, all the liquid is out of the funnel or out of my beaker at this time. So what I'm going to do is I'm going to use my DI bottle, and I'm going to kind of squirt this. So let me have this up a little bit, and I'm going to kind of hold this at an angle and kind of squirt this to try to get that silver to fall down, because I want that silver, of course, to get into my beaker or my filter from my beaker. And so I kind of have to use some gravity and some liquid to kind of get that to fall out. Try that. I can use a stir rod, but I'm trying not to have to use any other pieces of equipment, just because that can affect my results, because I don't want to have something else I have to clean or wash or rinse. It's almost there. Can you see it kind of falling to the side? It will come. There it goes. You see that big clump that fell in there? There's another big clump that fell in. Okay, and then I'm just going to kind of rinse the sides of this. So I'm just rinsing the sides, because see how there's like little specks of stuff in there? I want to get all of that out of the beaker and into my funnel, because that silver is part of what I need to measure at the end. So that's what I'm doing. So I'm rinsing the sides of this with the DI water. The DI water will just keep filtering, so that doesn't affect my results at all. And then I'm just making sure that this is clean. So take a look at this. We're trying to make sure that there's no more specks of silver in there, because I want all of my lab sample to be in this filter, so that when I measure it in part 3, I've got all the silver that I made. So let me just kind of rinse this one more time, because if I don't get the silver out of here and my percent yield is less than 100, that could explain that some of my little specks of silver were in my beaker and I wasn't able to remove them. All right, so you can kind of see what's going on here. So you can see that there's that filtering happening. You can see the copper 2 nitrate, and I'm just gonna let this finish. So I'm gonna do the jump ahead video again. So at this point, I'm gonna let it finish filtering, and I will see you back here for part 3. And welcome to part 3 of our lab. Thanks again for joining me, or coming back, or continuing to watch the video. So the exciting thing today is that between part 2 and part 3, all the filtration should have finished, and also our filter paper and silver particles should be dry. Are you ready to see it? Here it is. So you can kind of see them. So you can see sort of like, it's kind of like fluffy, gray, grainy, filtery kind of particles, kind of hard to describe. Here, let me show it to you a little bit more. So here you can see it in the filter paper. So I'm going to carefully hold that up and take a look at it. But then I also want to make sure you notice some of the other things. So down in the center are our silver pieces. Like you would predict, they're kind of silvery or kind of shiny gray colored. But then notice we've got some other stuff. We have sort of this like purplish gray like around the edge, and then also some blue. Well, the blue is not a huge surprise because the copper 2 nitrate is blue. And so as that filtered, some of that stuck on the filter paper and then the water evaporated. And then the copper 2 nitrate is that bluish color that's there. But then some of that other kind of like, brownish, purplish color, that might be from the copper wire. So that might explain that. But we need to consider this because that's going to affect our lab data. So I'm going to take our mass of the dry filter plate paper and silver. So let's take a look at that. My balance reads 0, so I make sure that, and I carefully put this on here so it doesn't fall apart or I lose anything in there. And then we get our mass. So we'll record that. Looks like it's staying at 1.69. So 1.69 is what you record for filter plate paper plus silver. And then I'm going to say for observations of filter paper, there's a blue ring at the top. And there's sort of this like purple, gray, brown. I don't really know how to describe it. It really is kind of a blend of those colors on there, like shading. So something like that. So again, we're trying to explain the fact that there is like this like discoloration here that's kind of, like a purple, brown, gray. That's probably from the copper, but then for sure this blue rim is from the copper 2 nitrate. So when I get the mass and I say the mass is the filter paper plus silver, there's also that other stuff on there showing us that our silver is not perfectly pure. But to finish our lab really quick, what I'm going to do is I actually have a beaker of silver left over from other labs. And when this gets full, I actually donate it to our art department and they use it in some of their art projects. So I'm going to put the silver in there. So then that will be collected for future reference for other people to use and look at. So make sure all that silver gets in there. And then again, you can see that filter paper now a little bit more like that discoloration. So if you want to add any more observations to your data table, this gets thrown away. I will then wash our Erlenmeyer flask and our funnel, and then that will finish off our lab. So I will finish those things and do all my cleanup while you go work on your lab report. Remember, it's a full lab report where you are first going to be doing some calculations, right? So you're going to figure out how much product did we actually make. Remember, that comes from lab data. You're going to calculate your percent yield, which compares how much did you actually make from the lab data divided by what you thought you were going to make. That comes from your hypothesis calculations. And then you times it by 100 to put it in percent. And then there's an extra conclusion question, and then there's an extra conclusion question, and then there's also your CER conclusion. Your claim should just state what is your percent yield because that answers the lab essential question. Your evidence should be talking some about your lab data and how you use that lab data to get to percent yield. And then your reasoning needs to, like always, describe the chemistry that's going on. Talk about the chemical reaction that occurred. Where did silver come from? How come we didn't produce any more silver? Talk about what a limiting reactant is and how that applies to this lab. And then also, why did the reaction stop? That's the limiting reactant, that kind of idea. That's the reasoning behind why did we get the results that we did. The additional conclusion question, so the last part is, why isn't our percent yield 100%? I don't know what it exactly is because I haven't done the calculations, but it's probably not exactly 100. So if it's higher than 100, think about what happened in our lab. Think about all the equipment and the pieces. Why might it be a higher percent yield than's really possible? And if it's a less than 100%, again, think about the different parts of the lab. What could affect our production of silver so we didn't get as much as we thought we were going to? All right, that's the end of our 3-part lab. Thanks so much for being my partner. We'll see you next time.